Welcome back to Maui Huliau Foundation's Climate Literacy Virtual Classroom. In Part 3 of Unit 2, we are exploring extreme weather and how climate change contributes to the strength of these weather events. We'll explore recent hurricanes and catastrophic storms, as well as the increase in wildfires and droughts occurring in many regions around the world. Let's get started. If you recall from the climate versus weather lesson, weather is the condition of the atmosphere over a short period of time and can change within minutes or hours. Weather, on the other hand, is how the atmosphere behaves over a long period of time. When we talk about climate change, we talk about changes in the long-term average of weather. In this part, we will be discussing how climate change causes extreme weather events. Examples of extreme weather events include heat waves, droughts, hurricanes, flooding events, and tornadoes. Investigating links between our changing climate and extreme weather is known as attribution science. Attribution science is the process of determining whether extreme weather events, such as hurricanes, could have been caused by or attributed to climate change. To understand why it's tricky to link climate change and extreme weather, think of the common analogy used of a baseball player taking steroids, which are known to enhance performance in sports. You're probably thinking, what do steroids and baseball have in common with climate change? Imagine a baseball player who starts taking steroids. Compare a season after taking steroids to a previous season without steroids, and you see an increase in performance in how many home runs he's hit. If this is the only factor that has changed during this period, you can then conclude that the steroids are responsible for that increase in the probability of him hitting more home runs. However, you cannot say for certain that one particular home run was caused by the player's steroid use. Similarly, while it can be nearly impossible for scientists to determine whether a single extreme event, such as a strong hurricane, is directly caused by climate change, scientists can use models and analyze patterns in recent hurricanes to determine that climate change did make that strong hurricane more likely to occur. Check out the video Steroids, Baseball, and Climate Change in the Additional Resources folder. We've all heard that hurricanes are one of the most powerful and destructive forces on Earth. But have you ever wondered where they get their strength? Hurricanes begin to form when thunderstorms move over an area of low pressure and warm water. Although each system can be complicated to fully understand, we know of three factors that influence the strength of hurricanes. As we've learned from past units, sea surface temperature is increasing, but warming is not happening at the same rate. One term that you will hear a lot in climate science is anomaly. An anomaly is something that deviates or is different from what is standard, normal, or expected. For example, this map sea surface temperature anomalies from 1981 to 2010 uses the red and blue colors to map areas where the temperature was significantly higher or lower than what was expected. As you can see from the amount of red on the map, most of these anomalies were higher than normal temperatures. Scientists believe that these higher than normal sea surface temperatures are causing stronger hurricanes to form in the tropics. As is shown here, hurricanes in the tropics start out as thunderstorms. As the warm surface air rises or heat energy fuels the storm, they gain strength. The warmer the water, the more moisture in the air, and the bigger and stronger hurricanes can get. Recent studies of Atlantic hurricanes also suggest that climate change may also cause hurricanes to maintain their intensity for longer when they make landfall, making them even more destructive further inland. One of the greatest threats to life during a storm or hurricane comes from water in the form of a storm surge. A storm surge is water from the ocean that is pushed towards the shore by the force of the winds moving around the hurricane. Normal tidal ranges, or the difference between the high and low tide, vary a lot from place to place. This range can be from almost 0 feet to over 50 feet in some places. But using an average of about 2 feet, during a hurricane, this can increase to 15 to 20 feet, with some extreme storms reaching up to 30 feet in surge. With such a dramatic increase in water levels and pounding waves, this can cause extensive damage. Hurricane Harvey, Maria, and Katrina devastated coastal communities and caused extensive damage. Jet streams are fast flowing currents of air and can exist at both high and low levels of the atmosphere, and generally flow from west to east. The direction in which they flow is due to the Earth's rotation on its axis. Scientists are now studying ways in which climate change is changing the movement of the jet streams, as these changes may lead to more extreme weather events. For example, during the past several decades, the Arctic has warmed twice as fast as the rest of the northern hemisphere. Known as Arctic amplification, scientists have observed that the reduced temperature difference between the North Pole and the tropics can cause the polar jet streams to move slower from west to east and can create a greater dip or waviness in this movement, as illustrated by this model. While this change in the polar jet stream normally happens each summer, scientists are finding that the warming Arctic temperatures are increasing this change. These changes in the movement of the polar jet stream can cause changes in weather patterns all the way into the mid-latitudes. New studies by climate scientists are also showing that changes in the jet stream can cause blocking events, where weather systems stall out or get stuck in certain areas. This may cause longer droughts, floods, cold spells, and heat waves. This can also cause storms to stall and intensify in one region, rather than move away as they normally do. Understanding jet streams and wind patterns can be tricky. Check out the video, What is the Jet Stream, and the additional resources for more information. Extreme precipitation events are increasing and can lead to flooding in some regions. Floods are one of the deadliest weather-related hazards in the US. This map shows large flood events in North America, with the Southeast region experiencing a high number of events. In 2017, Hurricane Harvey brought extreme levels of precipitation when it made landfall in Texas, causing extensive flooding. We'll learn more about Hurricane Harvey in one of the activities. As we learn about extreme weather events, it's not just storms and hurricanes that are intensifying. Hotter and drier conditions are being recorded. This map of the US shows temperature changes comparing recent decades to the first half of the 1900s. Aside from some areas of the southeastern United States, there is an overall warming trend across the US, as can be seen from the red parts of the map, with the largest temperature difference happening during the winter months. If you recall, an anomaly is when something deviates or is different from what is standard, normal, or expected. This map shows the change in the number of days with a heat index of 90 degrees or higher since 1979. But note how some areas are recording colder temperatures. Yet, record-breaking temperatures continue to be recorded. In August 2020, Death Valley in California reached 130 degrees Fahrenheit, making it the hottest temperature in the US recorded in over 100 years. As we see longer and hotter summers, this results in an increase in droughts and wildfires. While the blocking weather systems caused by changes in jet streams can lead to more extreme precipitation events, they can also cause longer periods of drought by preventing low-pressure systems from bringing in clouds and rain. While much of the US is expected to experience an increase in rainfall and extreme precipitation events, part of the southwest US and Hawaii are expected to experience increasing drought conditions. As we experience drier and hotter conditions, these factors influence wildfires. As conditions get warmer, snow melts are recorded to melt earlier in the year, creating drier conditions for longer periods of time. These large forest fires are mostly driven by drought and wind. This past summer, states across the West Coast experienced one of the largest widespread wildfire events. This came after record-high summer temperatures were recorded. Hawaii has also experienced an increase in wildfires. In Part 4, we will go more in depth into other Hawaii-specific climate change impacts, including droughts and wildfires. Let's take a look at the activities in this section. In the first activity, Understanding Climate Extremes, we will explore the connection between climate change and extreme weather. In Attributing Extreme Weather to Climate Change, you will explore an interactive map of extreme weather events recorded. And in the last activity, we take a closer look at the hurricane events that occurred in 2017, some of the most extreme weather systems to make landfall in the US. Wrap up this section by taking the Part 3 quiz and check out the additional video resources.